Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about the applications of the auxiliary planes in engineering graphics. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So in our earlier deliberations, we have already discussed that the two views of an object, that is front view and top view, projected on the principal planes, vertical plane and the horizontal plane, are sometimes not sufficient to convey all the information regarding the object. Additional views called the auxiliary views, they are therefore projected on other planes known as the auxiliary planes. So these auxiliary planes, they are auxiliary inclined plane and the auxiliary vertical plane. So the applications of the auxiliary planes we have already discussed in the previous three lectures. So we have discussed about obtaining true length of the oblique line, obtaining auxiliary views of the oblique line, determination of the point view of a line and the edge view of a plane. And in this lecture we are going to discuss about evaluation of the shortest distance between a point and a line. And we are also going to discuss how we can use the method of auxiliary planes to evaluate shortest distance between two skew lines. So the skew lines, they are the ones which are neither parallel nor intersecting. Similarly, we have already discussed about evaluation of true size and the form of the oblique plane, and the other application of the auxiliary planes are, that is, obtaining the auxiliary views and the true shapes of the sections of the solid. So this we will be discussing while we are having discussions about sections of the solid. So the auxiliary views, they are very useful in finding solutions of the problems in the practical solid geometry. So the first application that we are going to discuss today is about determination of the shortest distance between an oblique line and a point which lies in the space. So here we have got the projections of the oblique line AB. So this is the front view of the oblique line A dash B dash. Now this one is the top view of the oblique line, that is small AB. And the front view, the coordinates of the front view and the top view, they have been provided to us. So besides this, we are also provided with the coordinates of the point R, which is located in the space. Now we need to use the method of the auxiliary planes to determine the shortest distance between point and a line. So here, first of all, we are going to draw the given set of data that is available with us onto our drawing sheet. So you see, so here we start with this. So the coordinates of the end A dash, R dash and B dash we have drawn. Similarly, the coordinates for A, R and B have been drawn. So this is the data which was available with us. So just like we have already discussed previously, that these are the projections of the oblique line. A dash B dash is the apparent length in elevation. AB, it is the apparent length of the oblique line in the plan. So the first thing we need to do in order to evaluate shortest distance between point and the line, that we need to determine the true length of the line. And once the true length of the line will be determined, once we draw an auxiliary vertical plane parallel to this projection, that is AB, which is there in the plan. Now we are going to draw projectors through A, R and B. Since this is AVP, so the projections obtained on AVP will be that of auxiliary elevation. So since auxiliary elevation is to be obtained on AVP, which has been drawn parallel to the plan projection line small a and small b, so the distances of the elevation, that is A dash, R dash and B dash from the original reference line XY need to be evaluated first, and then these distances, they will be transferred on the corresponding locus line projectors over there. So let us first of all transfer these projections so that we obtain the auxiliary elevation onto the AVP. So for point A, you can see the distance of point A dash is 10 millimeter above the HP. So we are going to draw 10 millimeter positive, that is in above the x1 y1 plane. Similarly for point R, this is the locus line for point R. The distance of point R dash above the horizontal plane is provided to us as 40 millimeter. So this distance we are going to transfer over here on the projection line corresponding to the locus of point R. Similarly for the point B, the distance of B dash is 30 millimeter above the XY line. So now the coordinate location of B1 dash, that is the auxiliary elevation, we are going to obtain 30 millimeter above the plane x1 y1. Now once we obtain these 3 points, so we can join A1 dash with B1 dash. Now the special characteristic about this particular projection, auxiliary projection, that is A1 dash, B1 dash and R1 dash, it is that since we had drawn our auxiliary vertical plane x1 y1 parallel to the plan projection line AB, so the projections of the line AB that have been obtained on AVP, that is A1 dash and B1 dash, this happens to be the true length of the line AB. Now we have been successfully able to evaluate or determine the true length of the line AB, which is A1 dash and the B1 dash. Having obtained this true length, so as usual we are going to carry out little bit extension of this line by around 10 to 15 millimeter and draw the second auxiliary plane, which will be an AIP. So since we are extending the elevation auxiliary view over here, so we are going to get next auxiliary plane, that is x2 y2, which is our AIP, auxiliary inclined plane, and any projection which is drawn on AIP will be called auxiliary plan. So here once again I am going to project A1 dash and B1 dash locus line. Similarly I am going to project R1 dash locus line, that is these two projectors I have drawn over here. After drawing these two projectors through these points A1 dash, B1 dash and R1 dash, now here I want to determine auxiliary plan onto AIP. So in order to determine auxiliary plan, I need to work out the distances of the plan, that is A, B and R, from this AVP, which is our intermediate reference plane. So x1 y1 is our new intermediate reference plane. So the original distances, that is 10 millimeter, 40 millimeter and 30 millimeter from the earlier reference plane xy, they have become redundant and non-applicable. So now the distances which will be applicable to draw this particular auxiliary plan will be the ones which are there from the x1 y1 AVP that we have drawn in the first iteration. Now what we need to do, we need to measure the distance of point A from x1 y1, we need to measure the distance of point B from x1 y1, and distance of point A and distance of point B from x1 y1, they are equal, since AB projection line was parallel to the AVP x1 y1, which was drawn parallel to plan projection line AB. So onto this locus line, this distance we have already measured, and we are going to transfer this distance onto the locus line of A1 dash and B1 dash. So both the projections of A and point B, they are going to converge. So they will be converging over there, right? Then the second point we want to draw over here is R. So you can see the distance of R. Again, using the divider, we are going to measure this distance from the AVP, that is x1 y1. So this distance will be transferred in front of this. So this distance will be transferred over here. So R2 point we have obtained, A2 and B2 point we have obtained. So we are going to join both of these points. Now you will find that surprisingly, even though we have taken only 3 points, but we have mentioned another point over here in between, S. So what is this point S? How we have developed this point S2 over here? So R2 is okay, it was this distance. A2 and B2, they have been obtained corresponding to this distance, but where from this point S has arrived? So this point S has arrived, since this is the point where our perpendicular from this point R1 dash will be appearing onto the true length basically, because you see we are required to work out the shortest distance between this line and this point, and this shortest distance will be obtained when we drop a perpendicular from point R1 dash. Just see, once we drop a perpendicular from the R1 dash point onto the line A1 dash, B1 dash, which is a true length, and once we drop this perpendicular, what will happen? We will have this point of intersection of this shortest distance onto the true length of the line. And once I drop this perpendicular, you see what happens? This perpendicular becomes parallel to this new plane x2 y2. Just check this out. This perpendicular R1 dash S1 dash, it becomes parallel to this auxiliary plane, that is AIP, which we have drawn x2 y2. And now you see, since this R1 dash S1 dash, it happens to be parallel to this plane x2 y2, so whatever projections R2 S2 we have obtained, this will be the true length of the shortest distance that we intended to determine at the start of this particular problem over here. So just see, this is point S. Now why we have written S2 alongside A2 B2? Because you see, this point S1 dash might have lied over here, it might have lied over here, it might have lied over here, or over here, or over here. But wherever this point S1 dash would have lied, if you are looking at the point view of the line, because we are looking at the true length from perpendicular orientation plane, auxiliary plane. So since this plane happens to be perpendicular to this line, so irrespective of whether this point lies here or here or here or here or here or here, you are going to get the convergence of A1 dash, B1 dash and S1 dash right at a point over here. That is, this complete picture gets converted into an edge view. And since this is an edge view where one point is R2 and where the second point of this straight line is A2, B2 and S2. So since all these 3 points, they have converged into a single point, because this line, which was containing 2 endpoints and one S1 dash point in between anywhere. So all these 3 points, since they have converged into a point view, so we very well remember very simple aspect, that distance between 2 points is the shortest distance basically. So since we have obtained the point view of the true length of the line, we have got the projection of the point over here. So the 2 points which we have obtained, these 2 points, once we join them, we are going to get the shortest distance or the true length of the shortest distance. And if this is the shortest distance, so obviously if this is the true length of the shortest distance, obviously then from R1 dash we need to draw perpendicular onto this true length, that is A1 dash and B1 dash, and wherever this perpendicular meets S1 dash, so obviously now we get this corollary of projections of line, that whenever any projection happens to be parallel to a plane, its true length will be obtained onto that particular plane. So this is what we have already discussed while we were discussing the rotation of the line as well. So if this projection happens to be parallel to this, then obviously this R2S2 will be our shortest distance. So either way around, we have proved that this distance is the true length, or this is the shortest distance between point R and our true length of the line, which happens to be A1 dash and B1 dash, because both of these points, they have been reduced to the point view, because we had taken this auxiliary plane perpendicular to the true length over there. Now having obtained this point S1 dash, now we have to once again backtrack this point onto the line AB projection and onto the projection A dash B dash in the front view. So this, we have obtained the location of the point S1 dash, which is nothing but the point of intersection of the shortest distance with the true length of the line. So then, just like earlier, we were just, you see, we were projecting these points first of all downwards, that is perpendicular to the plane XY. Then second, we were projecting all these A point, B point and R point while we were moving them forward. These projector lines, they were all perpendicular to X1, Y1. Now we know that the projections of A and A1 dash, they will be perpendicular to X1, Y1. Projections between B and B1 dash, again they will be perpendicular to X1, Y1. Projections between R and R1 dash, they will be again perpendicular to X1, Y1. Now we have to take these projections back. Projection of point S. So S1 dash, if I take it back, what I need to do from this point S1 dash, I need to drop a perpendicular onto X1, Y1, and I will be extending it till it meets my original projection line, that is plan projection line AB at point S over here. Or otherwise, in other words, if I take it, I have to draw a projector line which will be parallel to A1 dash, projector line which will be parallel to RR1 dash, another projector line from S1 dash which will be parallel to BB1 dash. So either I take projector parallel to these three projectors, or I take a projector perpendicular to this. It means the same. So now you see, I am going to project this back. Just see, I have taken this projection perpendicular. This projector blue line is parallel to the earlier three projectors which were drawn from A, R and B. Now they were drawn in forward direction. This has been drawn in backward. Now I have to locate the point S onto the line, projection line AB. So this was the projection in the plan. Now I want to again take this projector back so that I can locate the position of this point onto my elevation projection line A dash B dash. So just see, I have now taken it again perpendicular. So now you can see S dash, it is parallel to AA dash, it is parallel to RR dash, it is parallel to BB dash, or in other words, this is perpendicular to XY. So the moment I draw perpendicular from S, which lies on AB, to S dash, which is lying on A dash B dash, that is front view elevation. So I am able to locate this point in the front view, and this point is also located in the top view. And now what I need to do, I'll be joining this in the front view, I'll be joining this projection line in the top view. So it means that once I join both of these projectors, so this is the shortest distance apparent length which will be visible to me in the top view. R dash S dash will be the shortest distance apparent length which will be visible to an observer in the front view. So the apparent projections of the shortest distance which are visible in front view, that is R dash A dash, and similarly the shortest distance apparent length projection which is visible to an observer in the top view will be RS. So this way we have been able to determine the true length of the line, that is the shortest distance between point and a line, and this completes our question number 1 for this discussion. Now let's move on to the second question for today's lecture, that is, we want to evaluate or determine the shortest distance between the two skew lines. Now you can see these are two skew lines, A dash B dash and C dash D dash, that is, these are the front view, Again, A, B and C, D, they are the top views of the skew line. So what are skew lines? Let us define the skew lines. So skew lines are the lines which are neither parallel nor intersecting. So since they are neither parallel, so obviously you are not going to get equidistant between these points. So since they are not intersecting, so we need to work out if there is shortest distance between these two lines, how it will be projected in the front view, how it will be projected in the top view, and first of all we need to evaluate what is the amount of minimum distance, that is shortest distance, which lies between these two skew lines. So please see once again, A, B and C, D, these are two oblique lines. So we don't have the true lengths of these lines appearing in the front or the top view. So since these are the oblique lines, so we are getting A dash, B dash and AB as the apparent lengths in front view and the top view. Similarly for the oblique line CD, the coordinates of the front view, that is C dash, D dash, have been provided, and coordinates for the top view, that is small cd, have also been provided. So once we have been provided with these coordinates, now just like in the earlier cases, you have 4 starting point. You can get AIP parallel to A dash, B dash, work out the true length, or you can go parallel to C dash, D dash, evaluate the true length, and then once again we'll go perpendicular to it, convert the true length into a point view. Similarly, the third starting point can be, you can go parallel to the plan projection line CD and evaluate the true length of that and again go perpendicular to it. Or the fourth starting point can be, you can go parallel to the plan projection line AB and evaluate its true length. So 4 lines are available, 2 are available in the front view, two projection lines, they are available in the top view. So choice lies with us. We can pick up any one line and go parallel to it. So to begin with, we have to draw the projectors which are available with us. So just see, whatever data was available, we have drawn our projections corresponding to that given data, and having drawn the original projections, and as I told you, choice lies with you. Since I have left enough space over here, so I'm not going to draw my AIPs parallel to either A dash, B dash or C dash, D dash. So I can draw AVP either parallel to AB or parallel to CD plan projection line. So please check, clear of the image. Usually I would have drawn this AVP very close to this, but then it would have interfered with the existing lines which are available. So clear of the original image, as close as possible, I need to draw my auxiliary vertical plane x1, y1. Having drawn this AVP parallel to CD, now 4 projection lines I will be drawing. One from C, one from A, one from B and another one from D. So 4 projector lines I am going to draw, and corresponding distances I am going to pick up from the elevation, because on AVP the view which will be obtained, it is called auxiliary elevation. So since I am going to draw auxiliary elevation onto AVP, so the distances of these points in elevation I am going to pick up. So please see, the distance of C dash is 60. I have drawn 60 mm ahead of the plane. Distance of end A happens to be 30 millimeter. So I have drawn this distance equal to 30 millimeter. Distance of point B dash, this is 50 millimeter. So I have drawn this point B1 dash equal to 50 millimeter. Similarly, the distance of point D dash from XY reference plane, it happens to be 30 millimeter. So I have drawn this distance of D1 dash, which is my auxiliary elevation point, as 30 millimeter. Now you see, having drawn these 4 points, I know A and B is one line, C and D is another line. So I need to join A with B and C with D, that is A1 dash and B1 dash. These 2 points need to be joined. Similarly, C1 dash and D1 dash points, they also need to be joined. Now, the special characteristic about this particular auxiliary elevation which I have been able to obtain is that since I had drawn my AVP parallel to CD plan projection line, So onto this AVP, the projections which are obtained will have one special characteristic, that C1 dash D1 dash is going to be my true length. So it is very simple, fundamental. So I have drawn AVP parallel to the plan projection line CD. So the projections which will be obtained on AVP regarding point C and D, that is C1 dash and D1 dash, they will provide me true length. And having obtained this true length, same thing I am going to do as we did in the previous case. I am going to extend it little bit and then draw another plane another plane AIP, auxiliary plane AIP, which will be perpendicular to this true length. So please check, I am drawing x2 y2, which is my AIP now, and I am going to extend this true length over here. So one projection will be coming through C1 dash D1 dash, another projection will be coming through A1 dash, and one more will be coming through B1 dash. So you see three projectors I have drawn: projector 1, projector 2 and projector 3. And since this is AIP, so the projection which will be available on AIP will be auxiliary plan. So since I need to draw the auxiliary plan, so the distances of the plan from the intermediate AVP are to be taken over here. Mind you, the original distances of the plan from the original reference plane, that is XY, they have become redundant now. They are not usable, no longer usable. The distances which we require to draw auxiliary plan over here are the ones which are there from the new AVP, which we had drawn x1 y1 in the first iteration. So the distance of A, you can see it is this one. I don't know the distance, so I have to take the help of the compass, divider or the scale. So best method is you use the divider. Measure this distance using the divider, mark it over here, distance of A. This is my locus line, projector line of the A. So from here, mark this distance equal to A. Similarly, C and D distances are equal because CD happen to be parallel to AVP x1 y1. So just see, for CD I have been able to obtain this distance. Similarly, for the end B, please check, this is my distance of the point B in plan from AVP, from x1 y1. So I'll measure this distance and mark this distance over here. And the moment I join, once again, this point line AB, it is available to me over here like this, whereas this is the true length which I had obtained. So this is my true length which I had obtained. So I have been able to obtain the point view of the true length. Please check, I have been able to obtain point view of the true length over here. And once again, I have added another point F2 over here, because you see we want to determine 2 points of the shorter distance. A dash B dash, one point of the shorter distance will lie over here. This point we are going to name as E, because this is the smaller point. So A dash B dash is the smaller number. So any point of the shortest distance will appearing on this will be called E dash. Similarly, C dash D dash is the larger alphabet. So any point of the shortest distance which is going to appear over here will be named as F dash. So that is why I have written down C2, D2 and F2 over here. Why F2? Because there will be one point which will be F1 dash, which will be lying on this particular line, C1 dash, D1 dash. And since I have been able to successfully obtain the point view of this line, because I had my second auxiliary plane AIP x2 y2 perpendicular to this true length. So since this plane was perpendicular to the line C1 dash D1 dash, so whether my F1 dash lies here or here or here or here or here or here or here, so this would have lied on the same point view of the line. So since point view of the line has been obtained, so irrespective of the position of the point F1 dash onto this line, the point view will give me C2 D2 and F2 at the same place. So I have been able to obtain point view of the true length of the line CD. Now what I want to do now is, because point view of the true length has been obtained, so I will be dropping a perpendicular from this point view of the true length of the line onto my line A to B2. So once I drop this perpendicular, you see, once I drop this perpendicular, I would say that this is going to be my shortest distance between these two skew lines. This is going to be the shortest distance between these two skew lines. Why? Because I have been able to successfully achieve or derive the point view of the line. So F2 point is already lying onto this point view. So whatever projector I draw from the point view of the true length of the line onto the other line, that is A to B2, one point which I am going to obtain, its name will be E2, because E2 F2 is my shortest distance. So E2 and F2 is my shortest distance. So now I have been able to locate this point of intersection of the shortest distance, that is E2, onto my line A to B2. So this point E2 has been located while I have dropped the perpendicular from C to D2 onto my line A to B2 over here. So once E2 has been located, now I am going to take this point E2 back. Just see, just like all other points, they were moving forward. Now I have to move this point backward. So point E2 lies on A to B2. So point E2 has been located, and this distance we have said this is the shortest distance, and we will prove it just in a while. So since we have been able to obtain this point E2, which is the point of intersection of the shortest distance with the line A to B2, now I want to take this back. So how I will take this back? I have one projector, I have second projector, I have third projector, which have already been drawn in the forward direction. And what is the criteria or characteristic of these three projectors? These projectors, first of all, they are parallel to each other. Second, these projectors, they are perpendicular to the auxiliary inclined plane x2 y2. So in order to take this E2 back onto A1 dash B1 dash and locate the point E1 dash somewhere here, I need to draw fourth projector from E2 backwards, which will be parallel to the earlier three projectors which have already been drawn, and it will be parallel to the AIP x2 y2 which has been drawn over here. So just see, this is my shortest distance or the true length. Measure this and write it down. Shortest distance equal to 3 millimeter or 4 millimeter. Now I have to take this point E2 backwards. So in order to take E2 backwards, as I have already told you, three forward projectors are there. I'll be drawing a fourth projector backward parallel to these three or perpendicular to x2 y2. So just see, the blue one is the backward projector which is perpendicular to x2 y2, and you can check it is parallel to the earlier three projectors. What are the earlier three projectors? A1 dash A2, then C1 dash B1 D1 dash, and C2 and D2. Similarly B1 dash and B2. Now you see, having drawn this projector back, I have been able to locate point E1 dash onto the line A1 dash and B1 dash. Now having located this, now one point which has been located on the line A1 dash B1 dash, which is E1 dash. Now I want to locate another point F1 dash onto C1 dash and D1 dash. How I will be able to do it? I will be dropping once again one perpendicular from E1 dash onto the true length, which is C1 dash and D1 dash. So just see, I am dropping perpendicular from E1 dash onto C1 dash and D1 dash line, and I have been able to freeze the location of this point F1 dash. Earlier I was telling you F1 dash could have been here, could have been here, could have been here, could have been here, or could have been here. But now there is no uncertainty regarding the location of point F1 dash onto the line C1 dash and D1 dash. And now it verifies the fact that since E1 dash and F1 dash is perpendicular to this true length and this x2 y2 was also perpendicular to the true length, so E1 dash and F1 dash, this particular projection is parallel to x2 y2. So if the apparent length of the E1 dash F1 dash happens to be parallel to x2 y2, so my projection which is obtained E2 F2 will be the true length of the line, true length of the shortest distance. So since this is perpendicular to C1 dash D1 dash, and since this is perpendicular, so E1 dash F1 dash is parallel to x2 y2 plane of projection. So my apparent length E1 dash F1 dash being parallel to the plane of projection, so onto this plane of projection, whatever projection is obtained, E2 F2 will be the true length of the shortest distance. Now, having obtained E1 dash on A1 B1 dash, A1 dash B1 dash, and having obtained F1 dash on the line C1 dash D1 dash, I want to project both of these lines backward. So similarly, we had 4 projectors coming forward. Now we need to take 2 projectors going back. So E1 dash projector will be going on AB. It will give us E here. From here, we will take the projector upward. This will give us E dash over here. Similarly, F1 dash projector on C1 dash D1 dash, you take it back onto CD. So wherever it intersects CD, you will get point F, and then you take this point F upwards. You are going to get the location of the F dash in the front view. So please check this out. This is perpendicular. Now I want to move the projectors backwards from E1 dash over here. So E1 dash projector, once I take it back onto AB, it intersects here. Then I take it above, it intersects A dash B dash over here. Now second projector, F dash. If I take F1 dash onto the line CD, it is going to intersect at this point F. Now if I take it upwards, projector upwards, then I am able to locate point F dash onto C dash D dash. So once again, I'll just show you, repeat it. If I take E1 dash, so E1 dash was lying on A1 dash B1 dash. If I take this projector back, so wherever this projector intersects with AB, I get location of point E. Now you take it upwards, wherever this projector, because these projectors, they are vertically downwards, perpendicular to XY. So from E, I need to draw a projector perpendicular to XY. Wherever it meets front view A dash B dash, I get the location of the point E dash. Similarly, for point F1 dash, point F1 dash is lying on true length C1 dash D1 dash. So I need to take it back. If I take it back, it has to intersect top view projection CD. So wherever it is intersecting top view projector CD, I get point F. Now I need to take it upwards to show it this point in the elevation. So wherever, once I draw this projector upwards, backtrack it, make it to intersect with C dash D dash, I get the location of F dash. So I have been able to locate the front view distance E dash F dash, top view distance EF over here. So true length was 3 to 4 millimeter. So obviously these projections will be front view and the top view shorter than 3 to 4 millimeter. So you see, I have joined this E dash with F dash. I have been able to join E with F. So this distance also I can write. So I can write down over here, the true length of the shortest distance is equal to E2 F2 is equal to 3 to 4 millimeter. Front view of this projector, it is around 2.2 or 2 millimeter, whereas this projector is also approximately 2 millimeter. So I can write down the front view of the projector is E dash F dash is equal to 2. Top view of the projector, which is the shortest distance between two skew lines, this is equal to EF. So we have verified that this true length is bigger than or larger than apparent lengths of the shortest distance which are appearing in the front view or the top view. So this way, this was the procedure that how do we evaluate the shortest distance between two skew lines, and then we have to backtrack those shortest distances to make them appear in the front view as well as the top view. So with this, we complete our discussion on the topic of auxiliary planes, and in these 4 lectures we have seen that what are the different applications of the auxiliary planes and how we can use the auxiliary plane method in engineering graphics to address various issues. So thank you very much. So this was the entire complete discussion on the topic of the auxiliary plane. So I hope this would have made your fundamentals clear about the applications of the auxiliary planes in engineering graphics. So thank you very much. Thanks a lot.